Hello, welcome back. We've got another example. And this one we have a mixing tank. Initially it contains 2,000 pounds of liquid water. The tank is going to be fitted with two inlet pipes. One's delivering hot water with a mass flow rate of 0.8 pounds per second, and the other is delivering cold water at a mass flow rate of 1.2 pounds per second. Water is going to exit through the single exit pipe at a mass flow rate of 2.5 pounds per second. We need to determine the amount of water in pounds in the tank after 30 minutes. So that's our problem. So this one, obviously, we have multiple inlets. We have one outlet. So we are going to be using the summation form of our equation. And let's go ahead and write our equation out. So if you remember, we had dmcv dt. That's going to equal the summation over all the inlets of mn dot minus the summation over all the outlets of m out dot. That's our equation that we have when we have multiple inlets or multiple outlets. Now keep in mind our delta t here is 30 minutes. That was given to us. And now let's go ahead and let's look at this right-hand side. We need to figure out how many inlets we have. So we've got two inlets. We've got this hot water inlet, and then we've got the cold water inlet. And you can see the mass flow rates are shown in the picture. Then for the outlets, we have the one outlet, and M3 dot is shown here. So let's go ahead and let's fill in this right-hand side. We'll leave the left-hand side alone for now. So the time rate of change of the mass in the control volume is going to equal M1 dot, so that's our hot water, plus M2 dot for our cold water, minus M3 dot for the exit. Alright, so that's our right-hand side. So basically you just are going to sum up the mass flow rates for all of your inlets, subtract the sum of all of the mass flow rates for your outlets. Now we want to know the mass of water in the tank after 30 minutes. That means the value we are looking for is this right here. We want MCV. That's what we are looking for. So now if you look at this problem, can you kind of figure out how we might do that? And notice we've got this time given. So if you think about it, we've got this dt in the denominator here. What if we took this dt and multiplied it on the right side? Then we'd have a derivative on each side, and then y'all know what to do after that. Means we're going to integrate both sides. So let's go ahead and write that out. dmcv is going to equal m1 dot plus m2 dot minus m3 dot times dt. And now we integrate. Here we don't have anything. Let's just put 1 and 2 for state 1, state 2. And over here we have our times. This is dt, so we're going to integrate. Our limits here will be time. So let's put 0 and then 30 minutes. Now we're ready to integrate. So for this one, we'll have MCV, and instead of putting 2, that might get kind of confusing. Just know 2 is final. So let's put final here. And then we're going to subtract MCV. Instead of 1, let's put initial. I don't want it getting confused with these numbers up here. So that's our left side. Now when we integrate this side, we're just going to basically have M1 dot plus M2 dot minus M3 dot times the time. And let's go ahead and plug our values in. M1 dot was 0.8, and that's pounds per second. M2 dot was 1.2 pounds per second. And then M3 dot, we need to subtract that. That's 2.5 pounds per second. Now remember, when you integrate this, we'll write it out to the side here, we're going to get this whole thing times t, then you evaluate, right? That's what we're doing here. I just went ahead down here and plugged in all the numbers. So we've got this t. Now if we were to evaluate at 30 and then 0 and then subtract, the one you're going to be left with is this 30 minutes. So we've got 30 minutes. And now let's look at our units. Do the units look good there? What do y'all think? I'm thinking they don't look good. And the reason for that is we got seconds, then we have minutes. We need to have the same thing. To get rid of this problem, let's go ahead and convert. We'll do 60 seconds per minute. Then let's mark out all the units that cancel. We got minutes goes away. And now these all have seconds in the denominator, so this seconds cancels all that. So now look at the units we have left. We've got pounds. That's what we wanted. We wanted the amount of water in pounds. Perfect. Let's go ahead and multiply all of this out. So we're going to have MCV final minus MCV initial, and then that's going to equal negative 900 pounds. Now we've got this. Now we want to know the final value. That's what we're looking for. All right, so we started at a time of 0. We went 30 minutes. We need to figure out what our final mass is. We just know that the change between these two is negative 900. Now what should we do with this? If you look up in this picture, we have our initial mass in the control volume. It was 2,000 pounds. That means this 2,000 gets substituted in right here for the initial. So let's solve this equation for this term right here. And we'll plug in that 2,000 pounds for the initial. This will give us 2,000 pounds minus 900 pounds, which gives us 1,100 pounds. So after 30 minutes, we have reduced the amount of water in this tank down to 1,100 pounds. So basically that means there is more going out than there is coming in. And you can see that just by looking at these mass flow rate numbers. We got 0.8, 1.2. You add that up, that's 2 pounds per second coming in. We have 2.5 pounds per second going out. Okay, so there's an example on how to use this equation, how to find your inlet flows, your outlet flows, put them together, look at the conservation of mass. Hopefully you like that one. I will see you in the next example video.